Hello guys, welcome back to my channel. So today we're going to continue the lecture we started yesterday on the access control list. So this is a topology we're going to use for this for the labs, and so I'm going to build a new one that's just to mimic this particular one. So I'm going to launch a new packet tracer. Okay, I already have it here, and so I'm going to add 3 routers. Okay, and then I'm going to add the switches and then the PCs. So for the switches, I'm going to use the 2960. So I need one switch here. I need a switch here. I need one switch here and here. Okay. Then I need a bunch of PCs. I need one PC here, one here, 2 here, and 3 PCs here. And I also need some servers. I need one server here, here, right here, and that's it. I need a laptop. I need a laptop right here. Okay, and that's it. So now I'm going to cable all of them together. So I'm going to cable all of them together. I'm going to use the auto cabling. Okay, automatically choose cable type. So I'm going to use this one. So first the routers, and then routers to switches, now the switches to the endpoint devices. Next, I'm going to rename the devices according to our diagram here. So I'm going to rename the devices according to what I have here. FTP switch one. I'm going to rename exactly like this. So I'm going to come here. So this one's going to be our FTP. This is going to be our user 0. User 0. This is our switch switch 1. It really doesn't matter the switches, like this one switch 0 or switch 1. Okay, or switch 4. I'm just gonna make it switch 4 just so it makes more sense. Routers, this router number 1, router number 2, and router number 3. So I went ahead and renamed all the devices, okay, according to our diagram here. So all the devices have been renamed according to our diagram. So now I'm going to just add the annotations with the subnets, and yeah, and then also the subnets everywhere. As you can see, I'm not using the same cabling for the connecting with R1, R2, and R3. It's because I want to use a different type of routing. Okay. In the previous video, in this video, like in the experimental video, test video, I actually used dynamic routing, to connect all these routers and PCs, everything together. I want to use static routing. on the here. So but it doesn't make any difference. These devices are still going to be connected to each other. So right now I'm going to add the color the diagram. So here it's going to be color yellow, something like this. Okay, and okay. Yeah, this one, and then for this one it's going to be something like blue. I just come here, something like blue, I think. Yeah. Maybe this one is a little bit better. So I colored all the subnets already. The colors may not be exactly perfect, okay, but yeah, but this is exactly what you get. So next thing is I'm going to put the subnets in there. I'm going to use this. So this one's going to be 192.168.1.0/24. This one is 192.168.4.0/24. So all the subnets are in there. So I have the .4, .1, .2, .3, and also the subnets interconnecting the routers are there. The 172.16.10 and .20 are there. So I forgot to change the background. Right now I'm going to change the background. So to change the background, I just come here, backset background, browse, and I'm going to go to right here, packet tracer. Okay, I'm going to take this background. I'm going to use this one. Okay, yeah, apply. Okay, the background is there. You don't see it because it's actually very white. What I'm going to do, I'm going to push this diagram a little bit further down so you can see the background much clearer. Right, so I adjusted the background to fit into the image we have, and so everything is good here up to this moment. The only things left is we have to power on our devices, or the devices are all powered on, but they're not configured. So I'm going to start with the endpoint devices to configure them. First with the I'm going to start with the one network, the PC1. Go to PC1 and put an IP address. So the IP here is going to be static, 192.168.1.5. The subnet mask. The gateway is going to be .1. Okay, 1.1, and then our DNS server is .6. I should have started with the DNS server. Let me just close out here. This is our DNS and web server, so I should have started with that one. So that one IP address is .6. The same subnet mask. Gateway is .1. And the DNS server itself. Okay, so I'm going to come back later for the services because we have to configure web services here, but I just want to configure the IP addresses first. So this is done, and then the laptop, I'm going to put an IP address there. So .5 is here, .6 here, so this one is going to be .7. Could actually give any IP address, it doesn't really matter. And so this gateway is going to be .1 and DNS. Okay, I'm going to quickly do for this one. I just want to configure the IP address, and then we will configure the services. Okay. All right. So I put in the IP addresses to all the endpoint devices. Okay, and I made some bit of changes here. A little bit of change compared to the original diagram. So all the servers are in a .6. So like the DNS and web server will be a .6, and the FTP is going to be a .6, and the SNMP, the mail server, is going to be a .6. It's just to kind of create some kind of uniformity. And also I made sure that, just for the sake of easy visibility, like PC2 is going to be 192.168.2.2, okay, and it's going to be .3 here. And the same pattern is here, okay, on the 3 networks. This is going to be 192.168.3.4, 3.5, and 3.6. Okay, so we can double check in there. We'll come here. So this is this router here, this PC here. So I go into PC configuration. This is a .4, okay, because it's a user 4. And if I go to user 5, user 5 would be 8.5. okay, so same thing here and same thing here. The only I maintain these ones, okay, like here is a .5, okay, 192.168.1.5, okay, it's a .5. And so these two networks, I maintain the same pattern of naming, of IP addressing, like in the previous document. In the previous now you don't see a big difference between the two, but I think this is the new one. This is a new document, and then this one is the old one. Okay, this one has they're so similar you can't even spot the difference. But anyways, this is the old one. I'm going to lower it. This is the new one we just designed, and so everything is connected, but it's not configured yet. So which means none of these pieces can actually talk to the other PC on the other sides, except maybe the ones that are just local. Okay, like this PC can actually talk to this one already, but they cannot go over the router. Okay, so if I go here, if I go to a .2 here, I want to ping .3, I should be able to ping it. Okay, so ping 192.168.2.2, no, 2.3. I'm at .2, so I'm going to ping .3. That ping is responding because it's the same subnet, okay, but it cannot go across the router because you see the link is still down here. So I have to like make sure there's connectivity all over, and we're going to do that one all together. Okay, so yeah, let me just we'll start the configuration on the routers very soon. All right, by the way, before configuring the routers, we need to enable the services on the FTP, DNS, and the SNMP server. We're going to start with the DNS server. Clicking there, just double check the configuration is there. So now we go to services and make sure, and also for each one of these subnets, I make sure that the .1 is the router interface. Okay, so if it's this one, the router interface is going to be a .1. It's going to be 4.1 here. It's going to be 3.1 right here. It's going to be 2.1 right here. Okay, so the router interface on the LAN side is going to be a .1. Okay, so that's how I configure them, all of them. So let's enable the services first on the DNS and web server. We'll go to services here, and then we go first to the web server. It's already enabled. Usually it's enabled by default, but we can always double check that. So DNS is not enabled, so we're going to enable the DNS, and we enable the DNS and we'll add some domain names. First domain name we're going to add for the SNMP for the mail server. Let's add gmail.com. Okay, gmail.com, which is our mail server. Okay, this mail server here, which is the IP address of that mail server is .2, so it's going to be 192.168.2.6. okay, it's .6. So that's the IP, that's the domain name. Okay, so now we're going to add, and then one other thing we're going to add here on the DNS is just a general internet. We're going to call it cisco.com. Going to call it cisco.com. okay, and that cisco.com would be if anyone wants to go to the internet, which is our web server. The IP of that web server is going to be 192.168.1.6. so the IP of that web server is going to be 192.168.1.6. okay, so we'll add that one. Okay, now DNS and web server is all configured. Now the let's go first with the FTP. Okay, but for FTP we have to check what are the users that we had on the previous diagram. This one. Okay, this is the old one. So let me clear this one out. Okay, delete. Okay, delete it. All right, so now we're gonna go into the FTP and see what are the users that we have here on the FTP. Okay, and then we're going to mimic those same users. Go to services, FTP. So these are the various users that we created for FTP. Okay, so I'm going to do I'm going to screenshot this. I'm going to screenshot these users because I don't want to flip between screens all the time. So I'm just going to screenshot these users. These are the ones that we created. Okay, so I'm going to screenshot them, lower this, and so this is our real. Okay, so these are the users. Those are the users that we put on the FTP server. I'm going to put this side, click this one. Okay, so are those ones on our services. Okay, so services, FTP. So you see we have by default FTP always has one user with a Cisco, with the password of Cisco. So we're going to add new ones. Okay, so the first one we want to add is the laptop. Okay, LT laptop. Okay, and the password for that one is going to be Cisco, small letters, Cisco123. Okay, make sure FTP it has read, write, delete, everything, all rights permitted. Add. So the laptop is added as a user. Second user we want to add is the PC1. Okay, same thing, Cisco123. Read, write, delete, rename, everything added. Okay, added. And now I'm going to do it a little bit faster. So all the users have been added for FTP. This is by default. We added this one, LT. Okay, LT0, password Cisco, PC1, PC. We added all these users. So that's it for FTP. If I come back here, I have to delete this one. Okay, come back here. So just so we don't confuse them. So this is done. Okay. Is done. We added all those users. I'm going to, by the way, I'm going to save this diagram because who knows, a packet tracer might disappoint. So I'm going to save it. All right, so I saved our diagram as ACL Lab. Okay, this is the ACL Lab, the one we just created. And so so DNS and web server is done, FTP is done. Now the last one will be the SNMP. Let's go in there, and for the SNMP, we're going to do the same thing. We're going to first go to the old diagram and see what are the users, what's done there. So we're gonna here, this is the old one, it's not the same file. So go here, I'll go to services, SNMP. You see these are the users that have been allowed here. And also, by the way, I'm just gonna screenshot this before screenshotting. Okay, it's the same users, they have the same password, so that's very important. And I'm going to also screenshot this with the domain name that we added. So I'm going to do it right now. All right, so we had a screenshot of all the users on the SNMP server. We have user 1, user 5, 0, and so on. So I'm going to go into the SNMP and do exactly the same thing. Go to services, go to email, and then I'm just going to lower this one out. And then the first thing I want to add is the domain name for the mail server. It's going to be gmail.com. Okay, I'm going to set that. You have to click set, otherwise it's not going to work. So first thing, I'm going to add the users now. It's going to be, first one is going to be user 0. The password is Cisco 123, and then click here add. I'm going to add the user 5. Okay, user 5 right here, user 5, password Cisco 123, add. So all the users have been added. You know, you can double check, but all the users have been added, so everything is good. So technically the SNMP server is ready. Okay, it's ready. It's just gonna come here. Our SNMP server is ready, but for every user that we added, we actually have to go in there into each of those users and configure them to be able to receive email. Okay, just like if you have an email, you must configure your laptop to be able to receive your email. Okay, your laptop must have like whatever application that, if it's Gmail, you need Gmail something to be able to receive your email, or Windows, you must have the application that permits you to receive an email. So the same thing here. So I'm going to go to first thing, I'm going to go in here, and again I'm going to screenshot all these names. I think I lost the previous screenshot. So for all these users, we're going to configure their laptops to be able to receive emails. Okay, so we're going to start this on the far right end. We're going to go user 5 and user 4. Okay, so we'll go here, user 5. Okay, we're going to configure him to receive an email. We're going to go here, go to email here, click that one, and then you see here it's configured the mail. So for user 5, the name is user 5. Okay, user 5, and the email for that user 5 is user5@gmail.com, and the incoming email server gmail.com, and the outgoing email server is gmail.com. The username is user 5, and the password we gave was Cisco 123. Okay, easy to remember. So user okay, is it user 5? Okay, should be user 5. Okay, user 5. If you make an error here, everything's going to go wrong. Okay, you're not going to be able to receive an email. So it's user 5 gmail.com. Okay, gmail.com. Incoming email server is gmail.com, outgoing gmail.com, username user 5, password Cisco 123. It's exactly the same thing we did here. So I'm not making this up. If you go to user 5, this is what we put. Okay, user 5, and this is the password you gave, and this is the incoming and outgoing Gmail server. So that's why we have to configure to each one of them. So we're doing now for this one. Now we're going to do for user 4. Okay, so we're done for user 5. We'll close this one out. Now we're going to do for user 4 on the same site. So user 4 now, the same method. We'll go to email. So now it's going to be user 4. Okay, that's the username. And the user 4 at gmail.com. Okay. Incoming Gmail server, gmail.com. Outgoing gmail.com. Username user 4, sorry. Okay. Your name. Okay, this is just the name. Okay, but this is very important. The username is very important. This is what we configured. But this name we could give any name. Okay, but this is very important. Just for uniformity. So the password is going to be Cisco 123. Okay, now we save. I've done for this one and this one. I'm going to do this one, and this one off screen, and then I'm going to come back. But before then, let's close out here, go back to this diagram. So we've done for this one and this one. So now I'm going to do for the user 0, which is this one. Okay, they're exactly the same way. There's no difference, except that you have to use the same credentials we put on the SNMP server, and then the laptop and the PC one. Okay. Now everything is configured. The servers have all been configured, and the PCs and the laptops have all been set for to be able to receive emails. And the simple question is, let's say this laptop wants to send email to this other PC. Will that email work? If you have an answer, give me in the comment section. But I can give you the answer right away. It's not going to work. Why? Because even though the DNS server is here, okay, and the DNS server is going to be able to recognize the Gmail, the SNMP server domain name, that traffic has to go through our routers, okay, because the SNMP server is a server for email. So that email is not going to be able to go from laptop 0 to PC 1 unless when we have our connectivity fully going straight to this SNMP, full mesh connectivity between the SNMP servers and the users. Okay, so anyways, what is left right now is to make sure there's full mesh connectivity and that the routers can talk to each other, and that all the PCs and everything servers, they communicate to each other. Okay, so that's the next thing we're going to do right now. Alright, so right now we're going to go into each one of these routers and put in the IP addresses exactly how you see on the screen here. We're going to route number 1. We could actually we don't need to go to the command line interface. We just go right here. By the way, before doing that, let me just do something quickly. If I go to options, preferences, and I say, okay, just temporarily, I'm going to make visible the interfaces. Okay, just going to make our configurations quicker. So I'm going to go in here, and then I know on the G01 and G02, I know the IP address, I also know the IPC address. So I'm just going to G00 first. Okay, I'm going to turn that interface on, put an IP address 172.16.10.2. okay, I'm going to put the .2 here on the router 1. No, I'm going to put the .1. okay, it doesn't really make no difference. I'm going to put the .1 here, and then subnet mask is /30, so it's going to be 255.255.252. okay, and I'm going to go to the next interface, which is G01. Turn that interface on, and G01 is 192.168.4.1. okay, we set all the LAN facing interfaces of the router is going to be .1. okay, so that's going to be .1 here, and then G02 is going to be one network. So G02 here. Turn that interface on. So it's going to be 1.1. Okay, 1.1. Okay, now that's done. Again, close it. This router is done for just for the interface configuration. And go to router 2. Go to router 2, and you can just go on the config. You know, not CLI. It's much quicker just to go straight here. The G00 is turn that interface on, and this IP address is going to be 192.172.1.10.1. Okay. .2. Okay. .2, because we gave .1 on the other side. On this interface we give it .1, so here is going to be .2. So I'm going to put that subnet to be 255.255.252. Okay, and I'm going to move on to interface G01. Okay, G01, which is this other one here. Turn that interface on. IP address is going to be 172.16.20. I'm going to put it I'm going to put .1. Okay, put .1. Okay, and then the last interface is the G02, which is 192.168.2.1. Okay, G02. Turn that interface on, and the IP here is going to be 192.168.2.1. Okay, that's done for this one. So just in the same way I did for router 1 and router 2, I did for router 3 already. The interface have all been configured. You know, the interface have all been configured. So now the interfaces are configured, but still this network are still isolated. Okay, and to prove that, let's go to PC1. If I go to PC1, I try to ping, probably PC1, I'm going to be able to ping this other network. Okay, I'm going to be able to ping this other network, but in any case, I should not have full connectivity between the because we haven't defined how routing is going to be done between those sites. So let's try first to ping from PC1 to a laptop. Okay, so if I go to PC1, okay, and I ping the laptop, which is supposed to be a .7, okay, ping 192.168.1.7, responding, that's okay. Now I'm going to try to ping across the router, but on the other side with the 192.168.4.0, I should be able to ping. I think I should be able to ping. No, I shouldn't be able to ping. Okay, technically I should not be able to ping because there's no routing defined between the two different subnets. So anyway, it's going to be 4.6. Okay, as expected. Oh, pinging is working. All right, pinging is working. Yeah, I have to find an explanation for that, but anyways, there are two separate networks just separated, and so I should not be able to ping it, but yes, it's pinging is working, and it's packet tracer, but actually it doesn't. I should not be able to, since these two networks are separated by two different interfaces on the router. I should define on the router how those interfaces talk to each other on two different VLANs, and so that should not work. But anyways, let me try to ping the other interface of the same router. Okay, that's the 172.16.10. I'm going to try to ping that one. 172.16.10. Let's say .1, which is okay, because we said .1 was this directly, that's the interface on the router 1. Okay, but .2 is the interface on the router 2. I'm going to try to ping that one. Okay, .2 will be the interface on the router 2. Okay. Okay, that one is failing. That one is failing. Actually, that's what's supposed to be, because we haven't defined on this router how they should get to any other network. Let's say starting from this network. Okay, we haven't told this router, if you're coming from this network, how do you get to this one, or how do you get over to this one? We haven't told this router that one, and that's going to be done through routing. So that one failed. And if in the same way, if I go to, let's say, PC3, PC2 here, I try to ping any other network. I'm going to try to ping any other network from here. And even if ping works for some network and doesn't work for another one, we still need to define routing, the full mesh routing, okay? Because this packet tracer, sometimes some things work not the right way, okay? So anyways, I'm going to go here, command prompt for PC2. I'll try to ping. I'm going to try to ping the other interface of the routers. So I'm going to ping 172.16.10.1. Okay, not responding. That's okay. That's what I expected. That makes a lot more sense to me. And if I'm trying to ping the other side as well, there's the .20.1 this way, or .2, or doesn't matter. And by the way, I should be able to ping the interface on the router itself, okay, not the other side of the router or the same. Okay, so if I'm pinging, instead of .1, I'm pinging .2. .2 should respond because it's on the router. Okay, so in the same way, I should be able to ping this interface on the same router. Okay, which is going to be 20.21.1 here. I think that's the interface. That's the IP put there. 20.1 should as well respond. That's okay, because it's the same interface on the same router. So pinging that one, that's okay. But we should not be able to ping across. Okay, because it doesn't know how to get there. So if I'm pinging, let's say .2 now, which is router 3, okay, that one should fail. Okay, that makes sense. It fails. That's okay. That's okay. I still have to find an explanation for this one. I believe there is an explanation that is maybe clear, or maybe it's packet tracer. I have to find out, okay? But I'm not too sure why I was able to ping across the router to the other interface with a completely different VLAN. Anyways, the same thing here. I don't need to test it. So we're going to have to define how these PCs and laptops and all these servers are going to talk to each other, okay? Alright guys, as far as dynamic routing is concerned, making sure all these PCs and laptops, everything talk to each other. Initially I wanted to do static routing. I realized that with static routing I have to make a lot of put a lot of individual statements to each of these routers, and it doesn't really serve the purpose for me. I just want to do dynamic routing. It's going to be quicker and faster for me. So I'm going to do OSPF. I'm going to go into router 1. And I'm going to CLI mode. So I'm going to use OSPF for dynamic routing. Configure terminal. The first thing you want to put the host name. It's going to be R1. Okay, and then router OSPF. Okay, process 10. Okay, we're going to use process 10, and we're going to put the router ID. Router ID of okay, that's our router ID, and then we'll say network. We're going to define these two networks, the .4 and the .1, okay, and also the 16.10, okay. So those are the three networks we're going to define here. So network 192.168.1.0, okay, and it's going to ask for from us the wildcard bits. So it's going to be 0.0.0.255. Okay, then we'll provide the area 0, enter. Do the same thing for the for the 4 network. Okay, for the 4 network. Okay, that's quicker than all this, you know. Anyways, do the same thing for this other. We defined 3 subnets, this one and this one. Okay, these ones have been injected into OSPF. Now the last one is the 172.16.10, so we're going to inject that one. So it's 172.16.10.0 0.0.0.3. okay. I need to explain to you exactly why it's .3. okay. .3 actually just defines the so if you take anyways, that's in a separate video. I'm going to be able to explain exactly the wildcard bits, how you calculate them. So this one, basically, since this one is a /30, okay, so it's going to be a .3 instead of 255, which is the whole network. Okay, so it's going to be a .3 here. It's area 0. Okay, so OSPF is completely configured on router 1. Okay, I'm going to do the same thing for router 2. But before doing that, I have to go out here and save the configuration. Go to router 2. Go to CLI mode. Enable. Configure terminal. Host name is going to be router 2. Alright. And then router OSPF. Process 10. This is process. Okay, yeah, process 10. We're going to maintain the same process, but I don't think we have to, but maintain the same process for. Okay, so we'll give a router ID. It's going to be 2.2.2.2. okay, and then we'll define the networks. We're going to define here 3 networks. Okay, the 192.168.2.0, and then the 16.20.0 and 10.0 here. Okay, so let's start with the network 172.16.10.0. okay, 0.0.0.3. okay, area 0, and do the same thing for the 20. Okay, let me do the same thing for the 20. Okay, instead of 10 here, it's going to be 20. Okay, exactly the same thing. And now we're going to do the same thing now for the LAN facing interface, which is the 192.168. I'm trying to do very fast because I don't want this video to be too long. 168.2.0. okay, 0.0.0.255. okay, area 0. okay, go out of there and we'll show run just to be sure that we configure the right thing. All right, this is our OSPF configuration. Process 10, router ID, and then network are defined. So with that in mind, that's done. So I'm going to save the configuration, and I'm going to do quickly for R2 right. So on our router 2, configuration is done already. So I'm going to just do show run. You're going to see it's already done here. So for router 2, OSPF process 10, router ID, I put it 3.3.3.3, and then I added the 2 networks. Okay, so that's all done. Now we're going to test full mesh connectivity first between the routers and then between the endpoints. Okay, so we're going to here router 1, and we'll try to ping the other side. Okay, 172.16.2.20.1. I think that's right. No, that's .2. That's on router 2. Okay, router 3. Sorry. Okay, ping responding. Now from the router, let's try to ping an endpoint on router 3. Okay, going to ping, let's say user 5, which is IP would be 192.168. 3.5. Okay, that's the IP we give there, responding. That's good sign, which means now we're going to try to do end-to-end pinging from PC1 to router 5. Okay, and the same thing, we're going to this side we already tested it was working, so we don't need to test, but we still do that again. So go to PC1, we'll go to command prompt, we're going to ping PC5 from PC1. Okay, ping 192.168.3.5. okay, responding. Okay, perfect. So now we have end-to-end connectivity. We can actually ping PC3 as well. So let's just do ping PC3. It's going to be 2.3. Okay, that's the IP we gave for PC3 here, 2.3. So if we ping it, should be responding. If it's not responding, I need to find out why. All right, so it's responding. Okay, the first ping failed for some reason, maybe just because of the routing. All right, so everything is working fine. Our routing end-to-end connectivity is working for everything. This will be all for this video, but before leaving you, I want to just be sure that our FTP server or SNMP server is working. But I think I should reserve that for the next video. So we're going to test, make sure that there is FTP is working before we block it. Okay, first thing we test it's working, and then we apply an ACL that blocks that traffic. Okay, so everything's allowed. Now we're going to gradually block the host or the subnets that we want to block. Okay, so that's it for this video. Thanks very much for watching, and if you new here, please consider subscribing, leave me a comment, and thank you, and talk to you next time.